Yeah, hi guys, good morning. And in today's session, we'll continue talking about services. Okay, I mean, yesterday we haven't talked about services now, right? So, hopefully, in today's session, we'll try to complete services as well as replication controller, replication sets, as well as deployments. Okay, so let me share my screen. Okay, hope you guys can see my screen. Yes, can you see my screen?
Yes.
Yes, sir.
Okay. Let me try to connect to my master. My keygen is in downloads. Okay. Okay, this is master server, and if I'll go to root user and if I'll do kubectl get nodes, then let me see if these nodes are ready. Okay, so we can see one master and two worker nodes are running, right? Now let me check if we have any running pods. So kubectl get pods. Okay, so we can see one pod is running. It has been started 3 minutes before only. Okay, so so I have missed one important thing. Okay, so if you want to check the logs of the specific pod, right, then in this case we can use kubectl get logs and then the pod name. The server doesn't have a resource. Kubectl logs. Okay, so kubectl logs and then the pod name. This will help us to get the complete detailed logs of our pod. Okay, so what is happening, and if there are any kind of issues in launching our uh, pod. Okay, so now we'll get back to our topic, that is services. So as we have discussed yesterday, okay, so let me delete this running one. Okay, so kubectl get pods, and then let me try to delete the existing one. So kubectl delete pods iphone on. Okay, so I have deleted all the pods. I mean, as of now there are no pods running in my machine, right? So even if you see kubectl get services, here we can see there is only one service running, and that is default what which has been created along with our cluster. Okay, I haven't created any service as of now. Okay, now as we have discussed yesterday, so in services, how many types of services are available in Kubernetes? Basically, one is cluster IP, one is node port, and the third one is load balancer. Okay, and these services will help us to communicate with our pods. Okay, outside the cluster. Okay, outside the network we can go for node port, and within the cluster we can use cluster IP. So what is happening? So if you see this, for example, here I have one image. Okay, so if you see this, right, so this is the image of the cluster IP. Okay, and cluster IP is one of the default service of Kubernetes. Means if I have created any service without assigning any type to that service, then by default it will assume as cluster IP. Okay, if you want to create node port, then we need to mention iphone type equal to node port. So we'll see about that as well. Okay, so what is happening here when we create one service? Okay, so for example, assume that we have three pods: pod 1, pod 2, and pod 3. And in three pods we have three containers running on port number 80. Okay, container 1, container 2, and container 3, and each pod will get one specific IP address, right? So the moment we create any service, then the service will assign, I mean, the service we will be saying one IP address assigned to this service. Okay, so whenever we want to communicate with our pod 1, pod 2, pod 3, what will happen? We can communicate them with the help of this IP address. Okay, the IP which is being created to service, we call it as cluster IP. Okay, so now we'll see how can we create one cluster IP service. Okay, so create one pod using YAML and then create one service by using the below command. So first let me create one pod by using the YAML file. Okay, so if I'll do ls, here we can see one first.yaml which we have used yesterday. Okay, so if I'll do cat first.yaml, then we can see this will create one container with two labels, that is environment equal to prod and then name equal to saber. Okay, so how to create this? kubectl apply -f and then first.yaml. Okay, one pod has been created. Okay, so let me clear my screen, and if I'll do kubectl get pods -o wide, and then we can see first pod has been created and the status is running. It's been 12 seconds and this is the IP address of our pod. Okay, and this has been scheduled on worker 01. Okay, now if I'll do kubectl get services, sorry, kubectl get services, then we can see only one default service which has been created is available. Okay, so for example, now without creating any service, first let me try to connect to my pod with the help of this IP. Okay, because we already know that our container is running on port number 80, right? So what will happen, let us see. Let me go to my server. Okay, so let me also connect to my worker 01 and worker 02. Okay, let me copy this. Let me open git bash. Okay, this is my worker 01. I've connected to worker 01. Now let me try to connect to my worker 02 as well. Okay, so EC2 instances, select worker 02, connect SSH client, copy the command, and then launch one new git bash and paste. Okay, so this is my worker 02. For example, since as we have discussed, right, so cluster IP we cannot access outside the browser, right? So now what I will do is I will try to connect to my cluster. Okay, for example, I want to check 10.96.0.1, sorry, not this one. So I want to connect to the pod IP. Okay, so curl 10.244.1.8 okay, see what's happening. We can connect to our pod with the help of curl command. Okay, with the help of this IP. Okay, so same command I will try to execute this in my worker 01. Okay, let me copy this. Now let me try to access worker 01. Okay, we can get the output, and now let me try to access this on the worker 02. Okay, we can try to access to our container. So what was happening, basically port number 80 was open and we can able to access our pod within the same cluster. Okay, so apart from this, when we want to communicate from the front end to the back end and to the DB clusters, okay, we can also create services. Okay, apart from services, I mean, services are not only to redirect your traffic to the pods, it will also help us with the load balancing. Okay, means if suppose we have three pods here, right? So three pods, in three pods same containers are running on three different node machines, for example, then what service will do, whatever request is assigned to this service, then it will redirect to any of these pod machines if the label is same. Here if you see, the label of this pod is Nginx and pod 2 is also Nginx and pod 3 is Apache. So service will be mapped based upon the labels, and then it will redirect the traffic to the pods where the label is Nginx Okay, and the request will be redirected from the service IP. Okay, so it will also help us to load balancing as well. Okay, so now let me try to create one service. Okay, so already we have our pod running, so I will be creating one service to the existing pod. So I will use this command. Okay, so kubectl expose. Let me execute this on the master machine, and let me make some changes. Okay, so which pod, what we have created, that is first pod. What happened? Okay, first pod, and I want to expose this on the port number 8000, and the target port, basically target port will be the port related to our container on which our container is exposed, that is port number 80, right? And then hyphen name, service name. So what should be the service name? For example, test cluster IP. I can hit enter. Okay, and if I'll do kubectl get services. Okay, and if I'll do kubectl get services, what will happen? Here we can see one service has been created, test cluster IP, and this service is exposed on port number 8000. Okay, and here we haven't mentioned the type of the service. In this command, I haven't mentioned the type of the service, but still it has been taken the type as cluster IP, because as I have said, so this will be the default service which will get assigned. Okay, now if we'll do services -o wide, then here we can see the test service has been assigned with the label called environment equal to prod and name equal to software. Okay, and if you check this kubectl get pods -o wide, then this is our pod. Okay, sorry, I want to check the labels, right? Get pods show labels. Sorry, spelling mistake. LEBELS. Okay, so here we can see the label as environment equal to prod, name equal to subnet, and even the service is also mapped with the same label. So what will happen? Whatever the request we are seeing on this particular port, for example, this IP, for example, let me try to access this. Okay, curl 10.99.5.110 colon 8000. See, we can see the Nginx default page and the same thing. Okay, so let me copy this in my worker 01. We can access our Nginx page, and same thing I will be trying to access in my worker 02. Then still we will be able to access our Nginx page. So what was happening? Basically, any request which is been mapping towards port number, I mean the service IP and port number 8000, then that will be redirected to any of the port with the same label. Okay, so in our case, what was the label? The label name was environment equal to prod, name equal to sub. Okay, for example, now let me edit my YAML file and let me show you something. Okay, let me edit this YAML. Okay, let me remove these labels. I don't want any labels to be mapped to my pod. Okay, and let me use kubectl apply -f and then first.yaml. So what will happen? Okay, if you see this show labels, then there are no labels assigned to my pod. Okay, so let me clear this. Okay, so there are no labels assigned to my pod. Okay, and let me check this get services -o wide, and my service is running on port number 8000, and the labels will be environment equal to prod, name equal to service. Any port with these labels will be attached to my service. Now what happened in our case, I have removed the labels, right? So the service should not be listening. So let me try to curl now. Okay, curl 10.99.5.110 colon 8000. Okay, see what happened. Failed to connect to 10.99.5.110 port 8000 because we have created the service, but there is no pod assigned to that service. Basically, as I said, service will check for the label name. If there is any pod with the label called environment equal to prod, name equal to subnet, then the service will be redirecting to that pod. Okay, in our case, as of now, we have removed all the labels. So the service is available, but there are no pods assigned to the service. Okay, so that's the reason we will not be able to redirect any of the traffic. Okay, same thing if I'll try to execute on worker 01, clear screen worker 01, fail to connect. Okay, even if I'm trying to execute this on worker 02, this will get failed. Understood? Means labels are very important. Based upon the label name only, the service will be assigned to the pod. Okay, so that's where we need to use labels in our pods as well as in our services. Understood? Now if you again want to redirect the traffic to that particular container, so what I can do, I can make the changes in my YAML. Okay, I have added one label called environment equal to prod. Okay, and then name equal to server. Let me save this. Okay, now let me try to apply this again. Okay, there is syntax error. .yaml. Let me copy this. Let me go to my Visual Studio. Okay, basically colon, right? I have used equal to vi first.yaml, and then I need to use colon instead of equal to. Okay, now if I try to execute my YAML file again, apply. Let us see what will happen. Okay, so applied. Now if I check kubectl get pods -o wide, then we can see, sorry, I need to check the labels, right? -, show labels. So spelling mistake, LDB, LS. Okay, now we can see there are two labels attached, and to our services, kubectl get services -o wide, kubectl spelling. Okay, we can see both the labels are same. Okay, now if I'm trying to access my service, right, 10.99.5.110 colon 8000. Okay, see, now again we are able to access the Nginx page. So earlier also directly with the help of the pod IP we were trying to access, but what will happen if suppose something went wrong and this pod got restarted? Okay, then what will happen? The IP of the pod will get changed, but whereas the service will be same and all the pods will be connected to the service, right? So there is no chance in the service IP will get changed. Okay, so that's the reason always for the internal communication go for services. Okay, and service will select which pod needs to be attached to the service based upon the labels. Okay, this column we generally call it as selector. Okay, and these are nothing but our labels. Okay, so understood? Others, guys, everyone understood or not? Okay,
Bro, once again repeat it.
సో డౌట్ ఏముందో చెప్పు, ఏం అర్థం కాలే.
ఇప్పుడు ఇంజనీర్స్ కి క్లస్టర్ ఐపీ అని కామన్ బ్రో రెండిటికి?
ఆ సర్వీస్ పైన ఏదైతే రిక్వెస్ట్ వస్తుందో క్లస్టర్ ఐపీ సర్వీస్ మనం క్రియేట్ చేసినాం రైట్. సో ఆ సర్వీస్ కింద ఎన్ని పాడ్స్ ఉన్నాయి ఇప్పుడు? ఒక పాడ్ ఉంది.
ఒకటి ఉంది బ్రో.
ఓకే, సో బేసికల్లీ ఆ క్లస్టర్ మొత్తం ఎక్స్పోజ్ అయిపోతుంది ఆ పాడ్ కి. ఆ క్లస్టర్ లో ఫర్ ఎగ్జాంపుల్ 5 పాడ్స్ ఉన్నాయి మా దగ్గర, ఫస్ట్ పాడ్, సెకండ్ పాడ్, థర్డ్ పాడ్, ఫోర్త్ పాడ్. ఓకే, ఆ 4 పాడ్స్ కి కూడా లేబుల్ సేమ్ ఉంది, ఎన్వైరన్మెంట్ ఈక్వల్ టు prod. దీని ఏమైతుంది, service will check which label is attached to the service as well as to the pod. If the label is same, then it will consider all the 4 pods inside that service only. Okay, so whenever we are trying to access via cluster IP and then port number 8000, whatever we have exposed, then it will send the request to all the 4 pods.
బ్రో నిన్న పాడ్ మనది ఎర్రర్ వచ్చింది కదా సెకండ్. సో ఇప్పుడు లేబుల్ దగ్గర ఒకటే పెట్టాలా లేకపోతే?
లేబుల్ నీ ఇష్టము, నువ్వు ఎన్ని లేబుల్స్ ఇచ్చుకుంటావు ఇచ్చుకో. యాజ్ ఆఫ్ నౌ ఐ హావ్ క్రియేటెడ్ 2 labels. If you want, I can create 1 label as well. Label basically ఏంది, just a kind of naming convention, how you want to identify your pod. Okay, I want to identify my pod as environment, as a production pod, and the name of my pod can be Zaver. Okay, so that's up to you how you want to configure your labels.
Okay bro.
Okay. Okay, now what we have one more service. Okay, for example, now let me show you something else. kubectl get services -o wide. Okay, so we have this IP, right? So if suppose I'm trying to access this IP on browser on port number 8000, so what will happen? We will not be able to get any request over here because this is not exposed outside the world. Okay, so now if you want to expose your service outside the world, in that case we need to go for node port service. Okay, so in this case we need to go for node port service, and the default port number which can be assigned to node port is between 30,000 to 32,767 only. Okay, so any IP we can configure, but this should be between 30,000 to 32,767. Okay, so now let me create one more service with the name called, with the type called node port. Okay, let me copy this. Let me paste. Okay, and pod first pod. Okay, so this will be, I'm trying to expose to the existing pod, first pod. Okay, and the type of this service is node port. Earlier we haven't specified this -hyphen type for cluster IP. Okay, now I am trying to specify -hyphen type equal to node port, and then the port number on what it needs to be exposed is 8000. Okay, and then the target port of the container is 80, and then the name of my service. Okay, and let me hit enter. Okay, one node port service has been exposed. So if I'll check kubectl get services -o wide, then we can see node port service has been created. Okay, this will send out the request on 31,566. Okay, so this is listening all the requests between 31,566. Okay, and the same selector we have mapped with our pod, I mean prod as my label and saber as my label. Okay, so now if I try to access this node port service on the internet, okay, what will happen? For example, I want to access my application, right? So on master machine, let me copy this public IP colon, on which port it has been exposed, 31,566, right? So 31,566. 31,566. Okay. Okay, here we can see, welcome to Nginx page. Okay, I have been exposing this on my public IP, and this is the default port number which has been assigned. So node port IPs can be between the range of 30,000 to 32,767 only. Okay, ఏదైనా range తీసుకోవచ్చు. Okay, so if I'm trying to access this on public IP of my master, then we can access our Nginx page. Now if suppose someone is trying to access on the public IP of my worker01, what will happen? This will still send out the request to the same containers. Okay, see, we are able to access our application on worker01 IP address as well. And if I'm trying to access my application on worker02, IP is 139 public IP. Okay, and the port number will be same. Means any request which is coming on the port number 31,566 will be redirected to the ports with the same label. Okay, so this is how we can expose our containers, or I mean ports, to the outside the world. Okay, by just using node port service we can do this, whereas we can use cluster IP to communicate inside the cluster. Okay. So here I haven't, I mean, when I'm trying to expose my or create my node port service or cluster IP, right? So I haven't configured any of the labels here. I mean, in label evil, I haven't created any labels to my cluster IP service as well as node port service, but it has picked the labels of the default port. Whatever port I'm trying to configure, it has picked the same labels. Okay, and this command is generally what we call as imperative commands, because we are not executing this service with the help of YAML, right? Okay, so hope this is clear.
Clear.
If you want to expose all ports, we need to mention -, or no. Basically, the ports which the same label will be attached to the service, and service is already exposed. If you want to expose all the ports, then make sure all the ports are running with the same label. Okay. Right. And then okay, so if you'll see this, services will check the request which is sent on port and redirect that based on label. Okay, so whatever labels we have to the ports, the request will be sent out to that particular containers, I mean ports. Okay, so now what we have seen was imperative type of command. So if we'll try to create any YAML file, okay, so this is what we need to use. Okay, so let me first delete the existing service. How to delete the service? kubectl delete service and then service name. What is the service name? Test cluster IP. Okay, and I want to delete node port service as well. So I want to delete these two services. Okay, deleted. So if I'll do kubectl get services -provide, now we have only one default service available. Okay. Now, if you want to create any service with the help of YAML file, this is what we need to copy. Okay, let me explain you this YAML.
Bro,
Yes.
డిఫాల్ట్ డిలీట్ అవుతుందా బ్రో చేస్తే?
అవ్వదు, అది చేస్తే ఎట్లయితుంది నీకు డిఫాల్ట్ కాన్ఫిగరేషన్స్?
ఒకవేళ తెలియకుండా చేస్తే
ట్రై చేయి, ఏమవుతుందో.
ఓకే
ఓకే, డిలీట్ చేయి, ట్రై చేయి, ఏమవుతుందో చెప్పు నాకు.
అంటే ఇప్పుడు తెలియకుండా డిలీట్ అయిపోతే దాన్ని బ్యాకప్ తీసుకోవచ్చు, అసలు అవ్వదు అంటారు.
సర్వీస్ YAML ఫైల్ ఉంటే we can create or we can spin up. Okay. Or else what we can do, we can use -o YAML. I mean kubectl run nginx నిన్న చేసినామా ఫస్ట్ సెషన్ లో, we can do that to get the YAML. Okay, but that is default configuration, so what they have written, we are not aware of that.
Okay bro.
Okay, so this is our first service YAML file. Okay, so as we have discussed yesterday, so there will be 4 common fields: API version, kind, metadata, and specifications. Okay, so here In metadata, I am writing the name of my service. What should be the name of my service? So the name of my service will be first service. Okay. And then under specifications, what type of service we want to create, whether you want to create node pod or you want to create any cluster IP. Okay. And then again in port section, node pod, on which port number you want to expose. I want to expose my service on port number 32,000. Okay, and this will be the port number and this will be the target port. Okay, and here we can, in under selector, we are going to use type equal to app, means this is nothing but our label. So it will select all the ports with the label called app. Okay, so let me save this, and if I try to do cat service.yaml, okay, so this is our service, but here in our pod we don't have any labels, I mean any pod with the label called type equal to app. So let us see what will happen. Basically a service will get created, but there will be no pods configured to the service. Okay, so let me try to execute this. So kubectl apply -f and then service.yaml. Okay, so first service has been created. If you see kubectl get services -row wide, what will happen? One first service with the type called node port has been configured, and this is the IP address, and this has been exposed on the port number 32,000, and the label what it is trying to check for the ports is app. Okay, now kubectl describe service. So I just want to check the details of my services. Okay, describe what was my service name, first service. kubectl get services, or kubectl get services. Okay, first service first. Okay, so kubectl describe service and then service name. Okay, let us see the complete details. Okay, so here whenever I'm trying to do this, here we can see the details of our service. Okay, so this is the name, and the namespace is default. This is something what we haven't talked about. Okay, and the labels, basically we don't have any, and the selector type should be app. Basically this is what it is checking for the our ports. Okay, here we don't have any kind of targets basically. Okay, there are no endpoints. You will see this empty. Why? Because the service is not mapped with any of the container. Okay, for example, let me create the existing pod kubectl, or else let me try the existing YAML. Okay, vi first.yaml. So let me change this to app. Okay, environment equal to type. Okay, so we have configured this label, and if I'm trying to execute this YAML now, kubectl apply -f first.yaml. Okay, so if I check the labels of my pods, they'll get pods show labels. Sorry. Okay, we can see now we have created one new pod with the type called app. Okay, and the service is also checking on the same type of label. Okay, so now if I'll try to do this kubectl describe command, here we can see one endpoint has been created. Basically this endpoint is nothing but the endpoint of our pod. Okay, if I'll check this kubectl get pods -row wide. Sorry, spellings, I'm missing L always. Okay, so this is the IP of our pod which has been assigned as an endpoint to our service. So if suppose you want to check to this service what are the different ports assigned, then we can check by using kubectl describe service and service name, and in endpoints we can check how many ports has been assigned to our services. Okay, now if I'm trying to access my service on port number 32,000, for example, we can access the Nginx page. For example, now let me try to create one more pod by using same YAML. Okay, va first.yaml. I'm just changing the pod name. Okay, the pod name will be second pod, and then the container will be second container. Okay, I'm just changing these configurations. Okay. What will happen? It will get override because we are using declarative object configurations, right? So if I execute apply, then this will get changed. So let me try to do one thing. kubectl create -f. Let me use create, okay, because I don't want to override. Okay, one more pod has been created. If you'll see kubectl get pods -o wide. Okay, this pod is also created and with the same labels. You will see this -show -labels. Then we can see both this pod with the same labels has been created. Okay, and if I'll try to describe my service now, we can see two different endpoints. Describe service name. Then here we can see two endpoints has been created. One is the IP address of my first pod, and the second one is the IP address of my second pod. Means this service has been attached to these two pods. And how this is being getting attached? Based upon the selector. In selector of the service, what we have given, type equal to app. Anything with type equal to app should be mapped to the service. Okay, so we have two containers, and these two containers, two pods, and these two pods are with the same label called app. Okay, so this is how we can create our service with the help of YAML file. And if you want to get the details, how I am writing this node port number, then how to check? We can check this by using kubectl explain services. Here, services --- recursive. Then we can see what all things. See, type equal to string. This is what I have used. Okay, and then I have used under specifications. I have used port numbers. Okay, node port, and all this stuff. Clear? Anand, ready?
No.
Understood or not?
Yes.
కొంచెం అర్థమైందన్నా కొంచెం మిస్ అయిందన్నమాట. Guys, I can understand this is very confusing, but still this is the only way what we can go for. Okay, so try to execute, try to read the documentation what I have given. Okay, try to execute each and every step in that. Then only you will get some hands-on and you will understand what is happening. Try to remove that label. Okay, try to put some different label. Okay, and then check. Then you will understand what it is doing. Okay, for example, let me show you this. In describe, we can find two different containers, right? So let me use same YAML file, and this time I'm trying to remove this label. Okay, and I'm trying to configure one more pod, third pod, and the container name is also third. Okay, so to this container there is no label. Okay, now let me try to create this kubectl create -f and then first.yaml. Okay, so we have got one more pod. So if I check this show label, so we have three pods, and for two only there is a label called app. Okay, if I will try to describe my pod, describe my service, what will happen? Here we can see only two endpoints, because this third one there was no label with the selector called app, so service has not integrated that. I mean, service has ignored it. Okay, so this is how If we have 100 of containers, then selectors are labeled and something which will help us to filter out which container we can use for which service. Okay. Now and then we have something called load balancer. Load balancer will check when we are working on AWS load balancings. Okay. And as I said, basically these services will also help us to load balancer our application. Means since if we have three applications, three pods running, for example, okay, if suppose we have three pods, pod 1, pod 2, pod 3, okay, if you have three pods with the same label, for example, the label type equal to app, here also type equal to app, and here also type equal to app. Okay, and then this is our service, and this service is nothing but our node pod. Okay, and the selector is based upon type equal to app. So what happened now? These three pods has been mapped to my node pod, right? I mean my node pod service. Okay, so whenever we are trying to access something on the specific port number, then what will happen? Okay, so the request can be sent out to any of these pods. Okay, it can send over first pod, second pod, or third pod. Okay, so this is also helping us with a kind of load balancing as well, because first time if I'm trying to access, then the request might send to pod 1, second time the request might send to pod 2, third time the request might send to pod 3. Okay, basically this will also work in I mean this services will also help us with the load balancing as well. Okay, so what kind of algorithm it will be using? It will be using random algorithm. Okay, so in order to distribute the load, this is using random algorithms. Okay, after this we have something called replication controller. Replication controller and replication sets both are almost similar. Okay, but what is the use of replication controller? For example, okay, now let me delete all my services. I don't want any service to be available. kubectl delete services. What are the different services we have created? Get services, kubectl delete service, and then first service. Okay, so kubectl get services. Now we have only one service, that is default one. Okay, so kubectl get pods. Okay, so we have one pod which is running. Okay, so for example, assume that this pod has been deleted for some reason, whether there was some issue and this has been deleted or this has been stopped. For example, kubectl delete pod and then pod time, first pod. So if I'll do kubectl get pods, we can see only two pods. So what's happening now? If this is our production environment and any of our pod is been getting deleted, then at least we need to maintain a set of pods. Okay, at least two pods should be running, at least three pods should be running, or there should be any kind of strategy which will help us to automatically create our pod. Whenever if any pod is deleted, then it should automatically create our pod. Okay, so for such kind of cases we have replication controller. So basically replication controller, and we can call it as RC as well. Okay, so we'll ensure that these many pods are running on the cluster. For any reason, if the pod is down, then RC will monitor that and spin up a new pod for us. Okay, RC will get attached to the pods based on labels and selectors. You need to remember this. Okay, even replication controllers are working based upon the labels and selectors only. Okay, so now let me try to create one RC. So let me try to copy this existing one. Okay, vi replication.yml, or else let me use rc.yml. Okay, hit enter and then let me paste this. I need to remove these comments because this is something which will not get executed, right? Okay, let me remove this. Let me add comments. Okay, so here the API version for the replication controller is v1 and the kind will be replication controller and the metadata. So basically this metadata is related to your replication controller. Okay, the name of this replication controller will be first RC and the labels what we are connecting to our replication controller. Okay, the label for our replication controller will be test app. Okay, and then specifications, same concept. I mean API version, kind, metadata, and specification. In specification we are using two different fields in replication controller. One is replicas, how many pods you want to run. Okay, in our case I am asking to run 5 pods at least. Okay, and then we are configuring the template. Under template section we are copying the template of our YAML. For example, if you'll see the first.yaml, right? Okay, under template we are copying this configurations till from metadata to, I mean this is something related to our pod. Okay, so this will be the pod name and this is something related to our containers. Okay, so what is happening now, inside replication we are creating our pods. Okay, so we are not using any separate YAML file to create pods. When we are trying to create our replication controller, our replication controller will also create our pods as well with the help of this detail. Understood? Okay, so this is, and here I am trying to execute 5 replicas. Okay, and the name of my pod will be first pod and the labels to which this pod will get created will be prod. Okay, and under specifications I will be using the image called nginx and the environmental variable for my container will be my name. Okay, so let me save this. Okay, and let me delete all the existing pods. kubectl delete pod, delete pod -1 all. Okay, so we don't have any pods now. kubectl get pods, so there are 0 pods. And if you see this, our YAML file, so with the help of this YAML file, this should create our pod. The pod name should be first pod and the number of pods should be 5. Okay, so let us see. kubectl apply -f rc. Okay, so replication controller or first RC, this was the name what I have created. Okay, so if you see kubectl get pods, here we can see 5 different pods are been running. Okay, so initially the name, if you see this, the name will be decided based upon the name what we have created to the replication controller, means first RC hyphen, then Kubernetes will pick any random ID to assign one name to our pods. Okay, so we have 5 pods running, and if you see kubectl get RC, we can see this was the replication controller what I have created. The desired was 5, current is 5, ready is also 5, and it has been spinned off from last 33 seconds. Okay, so this is how we can scale up our infrastructure. I mean, how many number of replica pods should be running at the same point of time. For example, for any reason one pod has been deleted, kubectl delete pod, and then let me try to delete this first pod. Okay, and if I'll try to see get RC, then still 5, 5, 5. Okay, but if you'll see this get pods, here we can see one pod has been deleted and one new pod has been created. 7FFP2 has been deleted. Okay, and then we can see one new pod, that is G2QZ9. This has been created. Okay, if you see kubectl describe, or else let me do one thing. Okay, kubectl get pods -w. So let me keep this on watch. Okay, let me clear the screen first. Okay, let me keep this on watch and let me try to connect to one more git bash terminal to same master machine. I want one more terminal now, only to show you what is happening when we are trying to execute this command. Okay, so copy. This is my master server, right? So open git bash. Okay, I have opened one more new terminal. Okay, sudo su -. Okay, here if I keep this page as well as this page. Okay, so here what I have did, I have executed get pods -w. So we are keeping this in monitoring. So let us see what will happen. Okay, and here I will try to delete one pod, kubectl get pods. Okay, and then kubectl delete pod and then the pod name. See here what happened on terminating. Okay, and then pending container creating terminating, and then one is been started again. So CJYS has been deleted and one new container has been created. So what's happening? Our cluster is maintaining minimum 5 containers at every time. Even if something is getting deleted, the new container will get created. Okay, so this is what replication controller will do for us. Okay, now if you get see this more details, kubectl get pods. Guys, understood this one? We'll move to some other topic. Okay, so F1 show, F1 labels. Okay, now here we can see the pods with the I mean, this pod has been assigned with the label called env equal to prod, because that's what we have written in the YAML file. Okay, now if suppose I will create one service. Okay, so we have already our service file as well, right? So let me edit the service.yaml, and here the type should be what was the type for this env equal to prod, right? So env equal to prod, and if I'll save this. Okay, now if I try to create my service, kubectl apply -f service. Okay, service has been created. Now if I try to describe my service, describe service, and the service name is first service. So see endpoints 1, 2, 3 and +2 means total 5 endpoints has been assigned. Basically how, if you see this services kubectl get services -o void. So the moment I have created one service with the label called env equal to prod, what this service has did, this service was checking if there are any pods with the same label. So it found 5 pods with the same label. And what service has did, service has grouped or mapped all that 5 pods inside this service. Means if I try to access service, then we can also access these 5 pods. Okay, understood? Yes or no? Ganesh, Anand, Raja.
Okay, no, clear.
Okay, so basically ఏమైతుంది, సర్వీ మనం ఆల్రెడీ 5 పార్ట్స్ క్రియేట్ అయినాయి. ఆ పార్ట్ కి లేబుల్ ఏముంది, ఎన్విరాన్మెంట్ ఈక్వల్ టు ప్రౌడ్ అని ఇచ్చినాం. మనం సేమ్ లేబుల్ తోనే ఒక సేమ్ సెలెక్టర్ తోనే ఒక సర్వీస్ క్రియేట్ చేస్తే సర్వీస్ ఏం చేస్తుంది, ఎన్ని పార్ట్స్ ఉన్నాయి అన్ని ఫిల్టర్ చేసుకుంటుంది, రైట్? సో మన కేసులో ఏమైంది, 5 పార్ట్స్ కి ఫిల్టర్ చేసుకున్నది, ఎందుకంటే ఉన్న 5 పార్ట్స్ సేమ్ లేబుల్ ఉంది కాబట్టి. సో ఇట్ హ్యాస్ గ్రూప్ ఆల్ ద 5 పార్ట్స్ into that service. So if I am trying to access that service, then we can also try to access our ports. Okay. Now one more thing. Okay, so kubectl describe rc, and what is the rc name? First rc. Okay, here we have configured the selector as prod, means any pod with this selector should be accessible. Here if you see, these are the type of events which has been attached. Okay, now if you show you this kubectl get, sorry, describe pod, or else let me do one thing. Okay, so let me show you something else. How to execute that? So basically what was happening is, it was checking for the label, I mean selector is prod, so it will create all the pods, right? So with the label pod. Okay, this is understood. Now what I want to do is, I want to create one pod. Okay, let me do one thing. Let me try to cat first.yaml. Okay, and let me change the label now. Okay, vi, what was our label, what we have used, env equal to prod, right? Let me use the same label. Okay, so first.yaml, metadata, to this pod I want to use this label. Okay, so now let me try to use kubectl create -f first.yaml. Values are not in this context. What was the error? Error emerged in the line 5, 1 2 3 4 5. Array labels and a pass here. I have just passed that directly labels. Okay, so LDBLS labels, spelling. Okay, env equal to prod. Now this is done. Now let me try to apply. Okay, created. So if you see this kubectl get pods, you can see what happened. Where is our pod now? Third pod. Get events. Invalid key was 0, image static kubelet, something happened. Now if I scroll up, this is 24 hours ago. Okay, 58 minutes. Okay, kubectl, I have created one new pod. Okay, so kubectl get pods 1 2 3 4 5. All this will not work. Yeah, first pod.yaml. Okay, now if you'll see this, what happened whenever I'm trying to create one new pod, right, with the same label prod, so it is not accepting. Okay, but why kubectl create -f first.yaml. kubectl describe pod, and then pod and third pod. if they are DHL. So basically what is happening? Okay, so replication controller, what we have said to maintain 5 pods with the specific labels. Okay, so whenever I'm trying to create a pod with the same label, so replication controller is checking, okay, already as the user has desired, 5 pods are already available, so it is not allowing any new pod to get created, so it is maintaining the quorum of 5. So let me do one thing, so let me go into the reverse process. Okay, so let me delete replication controller, kubectl delete rc, first rc. Okay, so what happened now? I've deleted my replication controller. Okay, kubectl get rc, so there are no replication controller configured in my machine. So if I'll do kubectl get pods, so all the pods which has been created with the help of replication controller has been deleted. Okay, now let me try to create one new pod, kubectl create -f and then first.yaml. Okay, now if I'll do kubectl get pods, we can see one pod is running, and then now I want to check the label -show labels. Okay, we can see one pod with the label called prod has been created. Okay, clear? Now let me see the rc. Okay, rc.yaml. Here what we want to do is we want to create 5 replicas. Okay, and the label or the selector should be prod. Okay, so what will happen? kubectl create -f rc.yaml. Okay, so I have created replication as well. If I'll do kubectl get pods, see what will happen. So it has created only 4 pods now. Why? Because replication controller has checked, okay, already a pod with the label called env equal to prod, and this has mapped into this replication controller. Okay, so basically replication controller will only help us to maintain, okay, 5 pods, what was my requirement, and it has checked already there is one container with the same label, so let me create only 4. Okay, so this was the same case why I was unable to create one pod with the help of YAML. Okay, so it will always check if there are any containers which are available. For example, if 2 containers were already running in my machine with the same label, then what replication controller will do? It will create only 3 containers. I'm sorry, 3 pods. Okay, so this is what the application controller will always try to check for the labels if there are any pods running in our machine, and if there is running, then it will try to create only 4. If it is not running, then it will create 5. For example, now kubectl delete pod. If third pod is deleted for some reason, let's see now what will happen. It will not create the third pod now. Basically, one new pod will get created with the same naming convention. See, 7 seconds ago this has been created. Okay, so this is how replication controller will check and ensure. But how replication controller is checking? Where can we see the details? For example, kubectl get pods. Okay, kubectl describe. The reason why I'm doing get pods to get all the details. Okay, so let me describe this pod. Spelling mistake. Let's describe pod and then pod name, right? Okay, here if I'll see this and if I'll scroll up, okay, here we can see something called controlled by. Means this particular pod is being controlled by replication controller. Okay, for example, let me delete my replication controller. So what will happen? All the pods will also get deleted, right? So kubectl delete rc, first rc. Okay, so all the pods has been deleted. Now let me try to create one new pod again. Create -f first.yaml. So I have created one new pod. So if I'll describe this kubectl describe pod and then pod name, spelling mistake, kubectl describe pod and pod name. And if I scroll up here, here we are unable to see anything in any detail like controlled by what we have seen here. Okay, here I mean, down to IP address, we can see something called control by replication controller. This was for the pod what we have created by replication controller. But in this case, we are unable to see this. Okay, so when we have created any pod without any replication controller, means what will happen? So whenever we are trying to create any pod, so replication controller will check if there is any owner assigned to this pod. If there is any owner assigned, then replication controller will create a new pod. If there is no owner assigned, then replication controller will become the owner for this. Okay, for example, when we have described third pod, we can see there is no owner configured, right? So what will happen now? kubectl get pods, we have only one running pod. So if I try to execute my replication controller, okay, kubectl create. Okay, now if I try to do kubectl get pods, we can see 4 pods has been created. One has been already existed and it has now controlled. Okay, for example, if I do describe now, describe pod third pod, and if I scroll up here, we can see controlled by replication controller. So what happened? Replication controller has become the owner for this pod now. Earlier there was no owner. So whenever we try to create RC, it will first check if there is any pod with a specific label is available. Yes, if yes, then it will check if there is any owner to this pod, if anyone is owning this, or if anyone is controlling this pod. If no one is controlling, then replication controller will try to control this, or else if someone is controlling, then it will try to create one more container for us. Clear? So that's how replication controller is working.
Savio,
Yes.
can we, I mean, after suppose we have replicas for like 5, right? If we create manually 2 with the first YAML file, and we can add plus 5, and we can add like 7. We can we can keep as primary as well as 5 replicas also. Right?
No. Basically, if the same pods what we are trying to create with replication controller and what the pods what you have created manually are having the same labels, then we can only maintain 5. We cannot maintain 7. That is not possible because replication controller is
can we specify more number?
Yeah, we can manage a 7, for example. Okay, vi rc. Okay, so this is our rc, right? So what I will do is I will change the number from 5 to 7 because we wanted to have 7 pods, right? So kubectl get pods. How many pods are running? 5. Okay, pods kubectl apply -f rc.yaml. Okay, so earlier I have created with the help of create, right? So what I need to do is, because I have used create, it was imperative object configuration. I need to use edit. Okay, edit. What was the command? kubectl edit rc first. Okay, here what I can do is I can make the specifications replicas void is 7 here. 1 second. Let me save this without any changes. Okay, this has been applied. Okay, it was throwing the warnings, but still it has been applied. Okay, so that's the reason we can see 7 here. Okay, so kubectl get pods, then we can see the number of pods which are running is 7. If you want to make it to 2, then you can make it to 2. Okay.
Okay.
If 2 pods are already running with the same labels and we have executed our RC with 7 number, what will happen? Only 5 pods will get created. And if there are no owners for the 2 pods, then that will be added into the same replication controller. Okay, So this is how we can use replication controller. Okay, and if you are adding any service file to this replication, right? I mean, if you are creating any service with the same pod, what will happen? Automatically, the service will be redirecting the traffic to all that 5 pods or 7 pods because the selector is same. So here it is only segregating or filtering out based upon the labels and selectors. Okay, that's the reason labels and selectors are very important. Okay. So this we have seen how to create RC and why do we need labels? If suppose we have 100 of containers running, then labels and selectors will help RS or RC guys. Okay, so RS is replication set. Okay, and RC is replication controller to filter the containers and apply monitoring based on labels and selectors. So basically what RC and RS will do, that will keep on monitor our pods. 5 pods is what the user has requested. Okay, so it will keep on monitor if there is any I mean, if there one pod has been deleted or any something happened, then it will try to create one new pod. Okay. So if you see this kubectl get pods -wide. Okay, then we can see on which worker node this has been created. Some has been launched on worker 02 and some has been launched on worker 01. Okay, so basically scheduler will check about this. Yes, Ganesh.
అన్న ఇది రిప్లికేషన్ యూజ్ చేసి మనం పార్ట్స్ క్రియేట్ చేస్తున్నాం కదా, అందులో మనం కంటైనర్స్ డిఫరెంట్ అప్లికేషన్ రన్ చేసినాం అనుకో.
ఓకే, ఏమైతుంది అప్పుడు సర్వీస్ ఉంటుంది. ఓకే, ఫర్ ఎగ్జాంపుల్ నువ్వు చెప్పినట్టు రెప్లికేషన్ కంట్రోలర్. ఓకే, లెట్ మీ డూ వన్ థింగ్. ఓకే, సో kubectl. ఓకే, ఆల్రెడీ ఇఫ్ ఐ చెక్ దిస్ kubectl get services, already మా దగ్గర నోట్బుక్ సర్వీస్ కాన్ఫిగర్ అయి ఉంది. 18 minutes ago we have did this. Okay, so if I will do the service describe service service. Okay, here we can see all the 7 ports has been mapped to this service on the port number 32,000. Okay, for example 32,000. If I'm trying to refresh what is happening, we can see our Nginx image. For example, if multiple applications, so let me reduce the size. Okay, kubectl. Let me edit my RC from 7 to 2, or else from 7 to 2. Let me reduce this. Okay, kubectl apply -f rc.yaml. So what will happen? Only 2 containers will be running. So kubectl get pods, sorry, 2 pods. I'm always stuck with these containers only. Okay, so only 2 pods we can see. Okay, so now let me do one more thing. So let me delete these RCs as well. Okay, so kubectl delete rc.yaml. Sorry, not rc.yaml, my first RC. Okay, so what I have did, I have deleted all my replication controller. I will do git pods. Now there are no pods running. Okay, so we have our YAML file, right? So first.yaml. So what I will do is here I will configure one image of HTTPD. Okay, now if I try to execute kubectl apply -f, everything, I mean my first YAML, my RC will be mapped to my service because of that label names. Okay, so first.yaml. So what will happen? One pod has been created, and if I try to access this pod, now we can see that HTTPD is working. So now what I will do, I will create one RC. అప్పుడు ఏమైతుంది? One pod will be of my HTTPD and one pod will be of my Nginx, right? So kubectl create -f rc.yaml, because it will only create 2, right? So already put on this, so one new will get created. Okay, so kubectl get pods. There if you see, sorry, what the hell is happening? So kubectl get pods. Okay, so we have 2 pods now. One, this has been created by RC where we were using Nginx image. Here we were using HTTP image. Okay, and both these are mapped to the same service. Okay, so if you want to check that as well, we can check kubectl describe service, and my service name is first service, I guess. Yes. Okay, so we have only two endpoints now. Okay, so if I'm trying to access or refresh this, as I have said, right, services will work on load balancing and on a algorithm called random. Okay, refresh. See, Nginx switching. If I'll refresh, same Nginx, refresh, 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 refresh. It is still stuck with the Nginx only. So let me use incognito. Sorry.
Auto scaling lekne work అవుతుందా?
Auto scaling kind of thing. Yes.
Okay.
So basically, what should happen? The request should fluctuate. Nginx kuda ravali, HTTP kuda ravali. Okay. So this will work based upon the algorithms.
ఫర్ ఎగ్జాంపుల్ ఇప్పుడు Nginx కంటైనర్ డిలీట్ అయిందనుకో మళ్ళీ ఇంకో కంటైనర్ క్రియేట్ చేసేటప్పుడు Nginx తోటే వస్తుంది కదా.
Yes, for example, now HTTP container delete them. Okay, because that we have created manually, right? The kubectl get ports. Okay, so if you see this kubectl delete port, third port, so what will happen? Kubectl command is not right. Okay, if I'm doing kubectl get ports, now we can see one new port with Nginx image has been created. If you want to get the more details, I can go wide, then we can see these are the IP addresses. So what happened now? It is also service is automatically getting attached based upon the label. RC is also getting attached based upon the label. So the pod, whatever we are trying to create, should have some labels to it, so that we can map it with our auto scalings, I can say, or with our exposing to the internet. Okay.
Okay.
Chapanand.
అన్న టిపికల్స్ అనేది డెల్టా వాల్యూ క్యాలిక్యులేషన్ తీసుకుంటాను కదా.
ఫోన్ పక్కకి వెళ్ళి ఇప్పుడు చెప్పు.
వెరిఫికేషన్ అనేది డెల్టా వాల్యూ క్యాలిక్యులేషన్ తీసుకుంటున్నాం
అంటే
ఇప్పుడు సరైన ఇన్ కేస్ మన రిప్లికస్ 7 అని ఇస్తే 7 పార్ట్స్ అండ్ రిప్లికస్ క్రియేట్ అవుతున్నాయి కదా. ఇఫ్ ఇన్ కేస్ నేను 2 అని మెన్షన్ చేస్తే అది డెల్టా వాల్యూ క్యాలిక్యులేషన్ చేసుకొని పార్ట్స్ అనేది రిమూవ్ చేస్తూ ఉంటుంది.
ఏం డెల్టా వాల్యూ అంటే ఏంది అది అర్థం కాలేదు నాకు ఫస్ట్. సరే అవి నీకు ఎందుకు అంత కష్టం ఉంది. వాట్ ఈస్ డెల్టా వాల్యూ అంత మ్యాథమెటిక్స్ రాదా నాకు కూడా. డెల్టా ఇస్ ద థియరిటికల్ ఎస్టిమేట్ ఆఫ్ హౌ మచ్ అన్ ఆప్షన్ ఏమేమి వస్తుంది కదా బ్రో. దట్ ఈస్ డెల్టా వాల్యూ ఇన్ కుబర్నెటిస్. ఏం అడిగినావు నాకు అసలు అర్థం కాలేదు. డెల్టా వాల్యూ అంటే వాట్ డూ యూ మీన్ బై డెల్టా వాల్యూ తెలియదు నాకు. Okay, so basically ఏమైతుంది, if the figure what we are giving is 7, then it will make sure to run 7 ports. If you are trying to make the changes to 2, then it will make sure to run 2 ports. ఓకే, ఇప్పుడు దాంట్లో డెల్టానో బీటానో అది నువ్వు డిసైడ్ చేయి, అది నాకు తెలియదు. ఓకే, చెక్ నేను కూడా చెక్ చేస్తా. బేసికల్లీ లెట్ మీ చెక్ ఆల్సో. డెల్టా వాల్యూ ఇన్ ఆర్సీ కదా, అది ఈసీ పెట్టేసినా కదా. Delta value in RC. I will also check, but as of now, I'm not sure on this. RC అంటే ఇది కెపాసిటర్. ఎలక్ట్రికల్ బ్యాక్గ్రౌండ్ ఏదాను ఎలక్ట్రికల్ బ్యాక్గ్రౌండ్ నుంచి వచ్చిరా ఆనంద్? ఎలక్ట్రికల్ బ్యాక్గ్రౌండ్ నువ్వు?
కాదన్నా, అది నేను విన్నా డెల్టా వాల్యూ అని.
ఫోన్ నువ్వు తీసి పక్కన పెడితే వాయిస్ లో డిస్టర్బెన్స్ రాదు. ఆ స్పీకర్ ఈ స్పీకర్ అది అయిపోతుంది. ఫోన్ తీసేయి.
గణేష్ ఓపెన్ చేసిన
సరే ఒక పని చేద్దాం. ఓకే, let us not discuss about that as of now, because even I am not sure, you are also not sure, right? So after this session we will try to check on that. Okay. ఏమంటావు ప్రొసీడ్ అవ్వనా మళ్ళీ నెక్స్ట్ టాపిక్ తోనే సూపర్ మీ అప్రూవల్ కోసం
there is no value there is no value as a delta used in Kubernetes as said in ChatGPT.
Yeah. Still taking I mean he has seen some references, right? So
yeah, I mentioned in the chat. Yeah. I mentioned in the chat the text what we got.
Okay. Okay. So then now, okay. So acha, one more thing. So here, what was happening? So whenever I was deleting my RC, all the pods were getting deleted, right? So if you get pods, so both these pods were also getting deleted whenever I will delete my RC. kubectl get RC. So both the pods were also getting deleted. So now my requirement is only RC should be deleted. My pods should be running. I don't want to delete pods. Okay. So what we can do, we have one command. What we can use is kubectl delete RC -f cascade equal to false. What it will do, it will help us to run the pods but delete the RC. Okay. Name of the RC is first RC. Okay, so replication controller first RC has been deleted. If you see this get RC, there is no RC available, but if you do get pods, then we can see two pods are still running. Okay, for example, now kubectl delete pod and then the pod name. Okay, now if I do kubectl get pod, will it create a new pod? No, because we can run these pods after deleting the RC as well, but if something happened and the pod got deleted, then it will not create a new pod because there is no replication controller for these pods. Okay, so we haven't configured any replication controller, so we will not be able to see new pods coming when something is getting deleted. Okay, see, one by one only, there are no pods. Okay, so this is something what I wanted to say. And apart from this, if you want to use the imperative commands to scale up, then you can use these commands. kubectl scale RC -f replicas equal to 6. What will happen on this pod? It will scale to 6, but there will be no change in terms of YAML. Okay, and this is also not recommended, but only for testing. If you want to check, then you can check. Okay, so what I have used is declarative object configuration and imperative object configuration. So these two things we have already used. If you want to use imperative commands, then you can check for this command as well. Okay, so see, as I have said, right, so RC will check if any pod with label is available or not, and if available, then it will check for the owner or someone controlling the pod. If no one is controlling, then the pod then the RC will be assigned to the pod. Okay, then the pod first correct only. Okay, so what was happening? So whenever we try to create some replication controller, what will happen? It will check if there is any pod with the label. Yes, then it will check if some owner is assigned. If assigned, then it will create new pod. It will ignore that and it will create a new pod. If there is no owner, then it will try to control that pod and it will not provision one new pod. Okay, basically it will only maintain F5, then it will maintain 5. If any existing one are running, then it will also consider them as the current one only. Okay, so this is how we can create our YAML file. So what I have used. Okay, so in YAML, so if you see this selector, so this is not mandatory. Okay, so basically this is not mandatory in replication controller. Okay, selector file is optional. Whether you want to use or you don't want to use, you cannot use. But if suppose we are not using the selector, what will happen? Then it will take the labels in count by default. Means whatever the labels we have configured to our pod, right? So that will be considered by default. Okay, so this is not mandatory in replication controller. Now when I talk about replication set, right? So this selector field is mandatory. So what is happening here? So replication set and replication controller, Okay, replication set and replication controller both are same in terms of purpose, means both are used to scale up our containers, okay, and map the containers based upon the selectors only. But RC replication controller is older technology, and Kubernetes recommend to not Kubernetes recommend to use replication sets, means the upgraded version of replication controller is replication set. Okay, RC is just the updated version of RP. RS is just the updated version of RP, but there might be some difference, right? So we are telling that there is almost same, the purpose is same, both are used to scale and maintain the number of pods, but there might be some change. So the change is in terms of selectors. So what will happen? So RC and RS functionality is almost similar. RC will work based on equality based selector, means we have two type of selectors now. One is equality based selector, one is set based selector. Okay, so what was happening earlier? So earlier, if suppose we have two pods, okay, if suppose we have two pods with the label called prod, if we are configuring replication controller, then it is to map. Okay, so RC selects all resources with key value to env and value equal to prod, means okay, anything with the label called env and the value as prod will be mapped. Okay, if the label is environment equal to prod, then replication controller will automatically map. But whereas in RS, what will happen is there might be a case where we might have two different labels or three different labels to our pods. In that case, it should work based upon the set based selector as well. So RS will work based upon equality based selector as well as set based selector. For example, environment equal to prod and test. So RS selects all resources with key equal to env and value equal to prod or test. For example, let me show you this. Okay, don't get confused. So let me show you this. So let me try to create one pod. So as of now, do we have any pods? Get pods. One pod is running. So let me delete this kubectl get, delete pods -f1 all. So we have, okay, kubectl delete pods -f1 all. So what happened? We have deleted all the pods. Kubectl get pods. So we have deleted all the pods. So there are no pods running on our machine, right? So now let me try to create one pod by using our first.yaml. So we have one pod. So let me edit this. I just want to make some changes. First.yaml. So this will be HTTPD. Okay, so let me make the change. First pod and second container. Sorry, first pod and first container, right? Let me create this. Okay, now if I'm trying to kubectl create, I'm using create command because I don't want to override this. Okay, -f and then first.yaml. So what happened? Kubectl get pods -show -labels. What happened? Command not found because this is not right. Okay, show the spelling. Okay, label. So what happened? So we have created one pod with the label called env equal to prod. So now let me try to create one more pod. Okay, so vi first.yaml. So let me change this. Second pod, and this one I will be changing the environment as test. On second container. Okay, so I will be creating one more container, sorry, one more pod. Okay, now if I'll do show labels, here we can see two pods are running, first pod and second pod with different labels now. Okay, so do we have any RC services configured? kubectl, sorry, RC, kubectl get RC. So okay, there is no RC created, right? So for example, if I am trying to create one RC, we have this RC, right? So RC.ml. So if I am trying to create this RC, what will happen? This replication controller will work. I mean, it will check for the label called prod, and this will map only one of my environment. For example, let me try to create this kubectl create -f and then rc.yaml. If I'll do kubectl, sorry, let me use kubectl -o show labels. Okay, here what is happening? So it has created one new port. Okay, and this has been access to only one port with the label called env equal to prod. So what is happening is RC will always check for the variable, okay, environment equal to prod. Okay, it will check only for environment and the value should be prod, then only it will map. So that one we call as equality based selector. But whereas for RS, what they have did is the environment can be either production or test. Okay, so environment can be either production or test, but still this should be mapped. If any values, okay, if the key value to environment and value equal to prod or test, then it should map to our RS. In this case, what will happen is, so whenever we create RS, so it will check if there are any particular labels with environment equal to prod or environment equal to test. Both should be mapped to my replication controller, I mean my replication set. So that's what we call as set based selector. So basically it will check for different values for the same label. That is also possible, right? So that's where we use RS. Okay, so this is the only change what we can change is replication sets rather than replication controllers. Okay, so now as we have created two ports, one is prod and one is test. Okay, now let me create one rs.yaml. Okay, so let me first try to delete the existing rs or else what happened. Clear, let me clear the screen first. Okay, so if you see this get rc, for example, kubectl get rc, my sorry, what was our rc name? First rc void describe. Okay, describe rc first rc void, then we can see the detail. Okay, here what the hell is happening? Kubectl describe rc and rc name. Okay, this is only one bot has been created. So guys, 1 second, let me get some details about my pods. Okay, I'll show labels. Get rc void. Okay, yeah. So now what we have did, so this first RC replication controller what we have created, this has been based upon the selector called env equal to prod, and this is mapped to these two pods. Okay, so for example, here we have one more pod env equal to test, but this is still not mapping. So that's what we can configure in our replication sets. Okay, that's where we call it as set based selector as well. So we have two type of selectors, one is equality based selector and one is set based selector. So replication controller is an example of equality based selector, and replication sets are the example for set based selectors. So let me try to copy this YAML file. Okay, so same YAML file. Okay, so I mean API version kind. Okay, the kind will be replica set and the metadata and the labels. Okay, this label is something related to your RC. Okay, and here specifications replica is equal to 2, and here we are configuring selector and we try different expressions. Okay, under expression the main value under key can be environment operator in. I mean here we can write only two type of operators, whether it can be in or not in. Okay, In operators, basically in environment, the values can be either prod or test. Okay, in the environment, the values can be either prod and test, and based upon these values, this should get created. Here, no need of this container details. If you want to create containers, then you can use or else no. Okay, so in my case, I will not be using this, or else let me use this as well, because I have only one container running, right? So copy vars.yaml and let me paste this. Okay, here see API version. This is the API version of our replica set, and the kind is replica set. Metadata, this is something related to our replication set. Okay, so name should be replica set, right? So let me change this. First RS, okay, and the labels what we want to assign to our replica set is app name equal to test app. Okay, and then specifications, how many replicas you want to create, 2, and where the selector can be based upon set based selector, means it can be either check for the value in environment, that is prod or test, and it can map. Okay, so replication sets will work, can be work based upon the equality based selector or set based selector. So both is possible for replica sets. Okay, so that's the reason Kubernetes is also recommending to use replica sets. Okay, and then inside template, this is the regular stuff. I mean, this is something related to our container. Okay, so this is something what we have seen in replica sets, not in replica controllers. Okay, so now let me save this. Okay, so here we have one RC that is been created. So what will happen is, so already the desired state for replication controller was 2, so there were 2 containers which are running, right? So now the desired state for RS what I have created will be 2 only. Okay, but here we can see one pod with label test is running, so it will only create one new pod. So it will use the selector as test, and then it will provision one new pod for us. Okay, so let us see kubectl create -f and then rs.yaml. Okay, so if I'll do get pod show label, so what will happen? See, only one pod has been created. The name or the label of the pod is prod, because this is what I have configured inside my RS, right? So, and if I'll do rc.o wide, then we can see, sorry, replication sets, I need to use RS. Okay, here we can see selector. In selector, it is trying to select from both the operations, whether it is production value or whether it is test environment. Okay, so this is how set based selector will be working. If suppose we have one more pod, okay, for example, let me show you this as well. So if suppose we have one more pod, okay, one is prod, one is test, and one pod with 2 different labels, prod and backend. Okay, and we want to ignore a specific pod, then how can we use this RS? Okay, for example, let me try to create one more pod. Okay, so first pod.yaml, this, the name will be third pod, and the environment is prod, and then type equal to backend. Okay, and then the container name will be also the third one only. Okay, so now let me try to create one more pod. Okay, so kubectl create -f and then first.yaml. Okay, and if I'll do kubectl get pods -f show -labels, spelling libels. Okay, so label. So what happened now? So we have created, what happened? Third pod is not running. Basically this RC has been overlapped. Okay, so let me delete the RC first. Okay, kubectl delete RC. What was my RC name? First RC. So let me delete Okay, and also let me delete kubectl, delete rs as well, delete rs. What was my rs name? First rs. Okay, so I have deleted everything. If I'll do kubectl get pods, I can show labels. So there are no pods running now. Okay, so now let me try to create one pod. Okay, now if I'll show you the labels, what we have configured to this pod, here we can see two labels has been assigned to this pod. The environment is prod and type equal to backend. And if I show you my RC, what will happen? Basically, this should check for the prod and this should map to my pod. Right? No new pod should be created. Only one pod should be created, right? So, but again, in this RS, we can add some more expressions. So basically what it can do is, it can select the values, I mean the labels from prod or test. Apart from that, it should ignore if there are any labels or pods which are running with the type equal to backend, then this can also ignore them as well. Okay, so that is also possible in rs. For example, here we can see, okay, same hyphen key operator not in. So in operator we have earlier we have used in, right? So in means it should allow, not in means it should ignore, okay, the values. So if there is any value as type equal to backend, then this should ignore this. Okay, so now let me try to create, because already we have one port, right? So let us see what will happen. Okay, vars.yaml. Now let me try to delete them. Okay, and now let me try to add this. Okay, so number of replicas equal to 3 means how many it should get created? It should create 3 now, because it should ignore the existing one. Okay, so in normal case, what was happening? It was creating only 2 pods and one was already there, so it was adding that only. So but now what will happen? kubectl create -f rs.yaml. Okay, so if I'll do kubectl get pods show label, see, this was already running. Now it has created only 3, because that's what our requirement was, to ignore the pods with the type as backend. So if I'll do kubectl describe, okay, let me describe this, get rs-o wide, then here we can see environment in prod, it can be either prod or test, and type should not be backend. So this is how we have configured our replica sets. Okay, so that's what we call as set based selector. I hope this was understood. I mean, this was clear. Are you ready? నీతోనే స్టార్ట్, అర్థమైందా నీకు?
అన్నా
చెప్పు బ్రో.
అర్థమైందన్నా.
అర్థమైందా?
నాది స్టార్ట్
ఆల్రెడీ చదివినావుట, మీరేం చెప్పేది, నేను ఆల్రెడీ చదువుకున్నా అట.
చదవలే అన్నా.
Okay, I think guys we are good with this. In again on Monday we'll start talking about deployments. Okay, so remember one thing, the only thing, I mean, whether we want to create any pod or to maintain the number of replicas, do not create, I mean, no need of creating multiple, I mean, first.yaml, all these files are not required. So we can have only one YAML file where we are going to write our replica sets as well as our pod creation as well. Okay, and then we are going to see one more topic called deployments. Again, in deployments we are only creating one deployment file. Inside that deployment file we are going to create our pods, and we are also going to create our replica sets inside the deployments only. Okay, so no need to worry that we are seeing multiple YAML files, but only for testing I am trying to create different YAML files so that I can go front and back, I mean I can delete, again execute, and show you guys. Okay, so once this is done, then make sure to delete all your services. kubectl delete rs first rc. Okay, do we have any other services here? RC is running? No. kubectl get pods. I think one pod is running. Okay, let me delete this kubectl. Delete pod -all. Okay, so now we have deleted. I mean, I don't have any clusters running. Okay, so I will be sharing these notes. Try to read this, try to execute this, and try to understand. If you are not able to understand, then again watch this video again and again, because I mean, there are a lot of components in Kubernetes that will make a kind of, I mean, that will create a kind of fuss in us, right? So make sure to watch this video again and again and try to collect some information, okay? And try to do more practicals. Thank you so much. Bye.